Hello, calculus fans. Let's talk about carbon-14 dating. So carbon-14 is an isotope of carbon. So remember that if you've taken chemistry, an isotope is a version of the atom where there are different numbers of neutrons in the nucleus. Carbon-14 is one with a larger number of neutrons than regular carbon, which is carbon-12. There's not a whole lot of carbon-14 around, and we can use it to date fossils. Carbon-14 has a half-life of 5,730 years. So carbon-14 will decay into ordinary carbon. But it takes 5,730 years for half of it to decay. Now, a particular fossil that we've unearthed has 3% of the carbon-14 that it would have had when alive, and this is due to radioactive decay. And the question we want to answer is, how old is the fossil? Now we can use our exponential growth model to analyze this, even though the amount of the carbon-14 is decreasing. So we're still going to use y of t is equal to y naught e to the kt. Now it takes 5,730 years for the half of the material to decay. So we have that y of 5,730 is 1/2 of y naught. So that means 1/2 y naught equals y naught e to the 5,730k. So we can divide by the y naughts, and then we'll solve for k. We'll end up with k is equal to 1 over 5,730 times log of 1/2. Notice that this k is a negative number. Log of 1/2 is a negative number. Remember that log of 1 is 0, so if you plug in anything less than 1 into the log function, you'll get a negative number. Now we're going to go ahead and let A be the age of the fossil, and we're going to try to solve for this. So y of A is equal to 0.03 y naught. Y naught is the amount that we're starting with. We're told that A years later, whatever that is, we have 3% of what we started with. So if we plug 0.03 y naught into the equation, we're going to try to solve for t. Just like before, these cancel out. And now we can try to solve for t by taking a log of both sides. Once we do that, then we can just divide by this whole mess here, and we've got our t. So we end up with t is equal to 5,730 log of 0.03 divided by log of 1/2. That works out to about 29,000. So our conclusion is that our fossil is approximately 29,000 years old. Okay, that's all for now.